Hello students, in this lecture we will see one more numerical based on mesh analysis. Now determine the voltage V which causes I1 to be 0. This is the problem statement and they have already mentioned I1 over here. Okay, I1 is one of the mesh current and they are saying you find out the value of V such that it will make I1 to be 0. Okay, so in such numerical we'll prefer mesh analysis. So I am assuming I2 over here, because already one mesh current has been marked in a clockwise manner, and here I am assuming the current as I3. I will form the equation in terms of I1, I2, I3 and V. So I will have 4 unknowns, but I will have only 3 equations. But then I will say it, or you can have some tricky method and you can have I1 to be 0 and you can find out the value of V. So basically you have 3 unknowns and 3 equations. So KVL in mesh 1. So when you apply KVL in mesh 1, you have to assign the sign for the voltages developed across the resistances. So these are the signs for the voltages across the resistance. I have explained this thing in previous lectures also. So I am starting at this point, leaving sign 20 plus 20, then I will have minus 6I1 minus 2 times I1 minus I2. Then I will have minus 5 times I1 minus I3. Here I will have leaving sign as minus, so minus V is equal to 0. Okay, so when you solve this thing, you will have 20 minus 6I1 minus 2I1 plus 2I2 minus 5I1 plus 5I3 minus V is equal to 0. Now I will arrange the terms in such a manner that I1, I2, I3 will be on one side and constants on another side. So this will lead to 13 times I1 minus 2 times I2 minus 5 times I3 is equal to, and right hand side is nothing but 20 minus V. You can check this thing. So this is my equation number 1. Now I will apply KVL in mesh 2. So that I am writing over here, KVL in mesh 2. But before applying KVL in mesh 2, you have to assign the sign for the voltages. So plus minus and plus minus. So I am starting at this point, minus 3 times I2. Go ahead, minus 1 times I2 minus I3. Then I will have minus 2 times I2 minus I1. And you have completed the loop. So that is equal to 0. So minus 3 times I2 minus I2 plus 1 time I3 minus 2 I2 plus 2 I1 is equal to 0. So we'll arrange the terms in such a manner that the coefficient of I2 will be positive. So this leads to minus 2 times I1 plus 6 times I2. Then I will have minus 1 time I3 and that is equal to 0. And this is my equation number 2. Then KVL in mesh 3. So here I am writing KVL in mesh 3. Okay. So I assign the sign for the voltages this manner, plus minus and plus minus over here. This is across 5 volt. Okay. So I am starting at this point. So this will give me minus 4 times I3. Go ahead, plus V. Okay, here it will be plus V, leaving sign because I am going in upward manner, upward direction. So I will have minus 5 times I3 minus I1. And then I will have minus 1 times I3 minus I2. And I have completed the loop is equal to 0. So I will have minus 4 times I3 plus V minus 5 times I3 plus 5 times I1 minus 1 time I3 plus 1 time I2 is equal to 0. So we will arrange the terms in such a manner that I1, I2, I3 will be on one side with coefficient of I3 as positive. So this leads to minus 5 times I1 minus 1 time I2 plus 10 times I3 is equal to plus V. And this is my equation number 3. Okay, you can check this thing. Now after this I will write down these 3 equations in matrix format. So when you are writing this equation matrix format, from equation number 1, what I will have 13 minus 2 minus 5, and here I will have I1, I2, I3, and the right hand side is 20 minus v. Okay, this is from equation number 1. From equation number 2 I will have minus 2, 6, minus 1 and over here 0. Here I will have minus 5, minus 1, 10 and plus v over here. Okay. Now we will see this thing. They are saying I1 to be 0. So you are aware of Kramer's rule. Okay. Since the value of I1 is particularly made to be 0, that's why you are using this simplified method. If I1 is set to some non-zero value, then this Kramer's rule technique is not that much useful. Since I1 value is set to be 0, I am using this method. So according to the Kramer's rule, you are aware of that thing at a determinant method. I1 can be calculated as delta 1 by delta. What is delta 1? Delta 1 is nothing but determinant of this matrix. This thing has been done in mathematics. Determinant of this matrix with replacing the first column by these constants. And delta is nothing but determinant of this matrix. But what they are saying, you have to set I1 to be 0. So I am setting I1 to be 0. So that means simply you want delta 1 to be 0, because delta will get multiplied with this one and I will have delta 1 to be 0. So what is delta 1? Delta 1 is nothing but determinant of this matrix by replacing first column by these constants. Okay, so I will have 20 minus v over here, 0 over here and v over here, first column. Second column will remain as it is, even the third column will remain as it is, and this determinant I have to set to 0. Now if you observe this thing, the task has been simplified because only one unknown is there, that is v, and we can easily calculate this thing. So when you are solving this determinant, you will have 20 minus v, and then you have 20 minus v will go in one bracket. Here you will have 60 minus 1. Then this will become minus, so it will become plus 2. I am solving the determinant, so this will lead to 0. This is minus v, so here it will become plus v. Then I will have minus 5, and then you have to solve this determinant, so this is 0 minus 6v, and that is equal to 0. Right hand side is 0. This right hand side I am writing over here. So when you solve this thing, that means 20 minus v into 59, then I will have plus 2v, and here I will have plus 30v is equal to 0. This will give me 1180 is equal to 7v. You can check this thing, and the value of v turns out to be 43.7 volt. Okay, so we have obtained the value of v. Okay, now can we use this method when I1 is said to be non-zero? So that we have to check. Okay, so we'll use different approach when I1 is set to some different value. So here the same numerical, but we have to calculate the value of v, which says that I1 is equal to 2 ampere. Okay, so first of all I will copy and paste the equation that I have written over here. So equation number 1 is 13i1 minus 2i2 minus 5i3 is equal to 20 minus v. So that I will write over here. So I will have 13i1 minus 2i2 minus 5i3 is equal to 20 minus v. This was my equation number 1. Okay, okay, I will mark I2 over here just for your reference, and of course I3 in the mesh 3. So this is I3 over here, and the mesh current 1 is. Equation number 2 was minus 2 times I1 plus 6 times I2 minus 1 time I3 is equal to 0. This was my equation number 2. You can check this thing. And equation number 3 was minus 5 times I1 minus 1 times I2 plus 10 times I3 is equal to plus v. This was my equation number 3. Okay, now we will not use that Kramer's rule method to solve this thing. Okay, so what we'll do, I1 is equal to 2 ampere, so we'll substitute I1 is equal to 2 ampere over here, and we'll form the equation in terms of I2, I3 and v. This is on one side, and the right hand side will be some constant. So this type of equation system we will solve, simultaneous equation. So when you substitute I1 is equal to 2, what will happen? This minus 2I2 will remain as it is, minus 5I3 will remain as it is. Okay, I will transfer V on LHS. So I will have plus V over here, rather plus 1V is equal to, when you substitute 2 over here, this will become actually 26. Okay, so here on the right hand side I will have 20 minus 26. V I have already transferred, 20 minus 26. So 20 minus 26, it will lead to minus 6 over here. So this will be my equation number, let's say 4. Okay, from this equation I will write 6 times I2. Okay, because you have to form the equation I2, I3 and V. Then I will have minus 1 I3, no problem. There is no V over here, so I will write 0 V over here is equal to plus 2 times I1, but I1 is 2, so this will become 4, 2 2s are 4. So this is my fifth equation. And the sixth equation will become, from equation number 3, I will have minus 1 time I2 plus 10 times I3 minus V is equal to plus 5 times I1. This, when you transfer RHS, I will have plus 5. So this will lead to 10. And this is my equation number 6. Okay. So this set of equation we have to solve. This contains 3 equations and there are 3 unknowns. And that is the fair thing in mathematics. One can use the calculator and they can calculate I1, I2, I3 and V. So I2 turns out to be 0.889 ampere. You can check this thing. I3 turns out to be 1.33 ampere and V turns out to be 2.44 volt. So this is my answer, or this V will cause I1 is equal to 2 ampere. So when I1 is non-zero value, you can adopt this method. Otherwise, if any current is said to be 0, you can use Cramer's rule. If they are saying I2 to be 0, then I would have written over here, I would have delta 2 by delta is equal to 0, and I would have equated delta 2 is equal to 0. And what is delta 2 over here? So you have to replace second column by this constant. Okay, and you have to solve the determinant and equate it to 0. So that is all about this video lecture. Thank you.